The first step of the procedure is to calibrate the camera. We've installed the camera on the robot arm onto the gripper, which allows us to use the robot as a station frame to hold the camera above the objects. But we need to calibrate the intrinsic parameters of the camera, why we have implemented an automatic calibration feature. So we will now start the MATLAB script that performs this calibration, which connects to the robot of which script we start, and the robot arm will then initialize, and we will in a minute start to see camera images being taken and saved for later calibration usage. And we are of course using this checkerboard mat to perform the calibration, of which we know the exact physical dimensions of each square, being 25.5 millimeters in this case. Now when the calibration is finished, we go back to the MATLAB terminal, where it has detected the images stored as bitmaps. So we tell it to use these bitmap images, and then we are using this camera calibration toolbox which detects the images, and now we have to type in the dimensions of the squares, in this case as mentioned being 25.5 millimeters. And when that has been typed in, the toolbox has been automated to do a corner detection to detect the features, these corners of the squares on the checkerboard. And after detecting all the corners in each image, these are used to progress and calibrate the intrinsic camera parameters, which we see here. So the calibration is finished, and now we see these extrinsic parameters. So the intrinsic parameters used in an extrinsic case, where we have the checkerboard mat here, and we have the individual robot positions from which it took the image pictures. And that matches up quite well with the individual parameters and angles. So that was the camera calibration. The next step is to calibrate the background for removal and to calibrate the color thresholds to be used in the segmentation, and finally to calibrate the camera to robot tool offset. And we initiate this combined calibration by starting the MATLAB script which connects to the robot, which will then initialize and go to a camera taking position, from where it will grab an image of the background to be used for the background subtraction. The next step is to place a brick in the hand of the robot, so we can calibrate the offset between the camera and the robot tool frame. So we use the Universal Robots Teach mode to move the robot arm to the position of the table, and we also place some bricks on the table for the color calibration. And then the robot will move up and take a picture of this placed green brick, which can be used to calibrate this offset. Next step is then to perform the color threshold calibration, which consists of selecting the pixel colors of each brick. Here the green brick, and next the blue brick. So we select a pixel region and use the normalized colors of this region to form a histogram, and choose the 5 and 95 percentile of this region to define our minimum and maximum threshold values. with these thresholds defined, the analysis can then be started. And here we see the segmented image with the blob detected. And finally, we have all the detected bricks and their rotation, so both the center and rotation, in the captured image. And we can finally test the calibration by making the robot go to the green brick and pick that up. And also go to the red brick to pick that up as a test. Alright, that was the robot calibration. Now with both the camera calibrated, the robot calibrated, and the calibration of the color thresholds, we can perform the actual stacking algorithm, which consists of starting the MATLAB script that connects to the robot, and starting the script on the robots, such that the robot will initialize to a camera taking position where it will grab an image of the bricks that we have placed on the table, as seen here. And this image is then used for the segmentation and the blob analysis, where it will process the bricks and calculate the features such as center and rotation, which can be included and used by the robot to pick up the bricks, as we see here. The robot will use these to pick up the bricks and stack them in an order of red, green, blue, yellow, orange. And then it will put the stack aside and do another one. And if there is no bricks available, it will do the first available brick, in this case, the yellow one. And there we go. Now we have stacked the bricks.